Hi, in this class I'm going to talk about how to use my step-to-step process to test hypothesis of Anova. This is chapter 13, and here is the critical value approach. So let's follow these steps using a real problem. Chemitech, the same problem we have in the previous video. Chemitech developed a new filtration system for municipal water supplies. There are different methods that can be used to assemble the system. Chemitech has narrowed down to 3 methods, A, B, and C, and wants to determine which assembly method can produce the greatest number of filtration systems per week. So Chemitech wants the most productivity system. They selected 15 workers and put 5 workers into each treatment. We have been through that. The factor is the assembly method. The treatment is A, B, and C. Assembly methods, experimental units are employees, and the response unit or dependent variable is the number of units produced. So here is the data. Here the worker 1, 2, 3, 4, and 5, and this is each one of the methods. This is how many filtration systems the employee 1 produced in group A. This is how many filtration systems the employee 1 of group B produced, and so on. Okay, so this is how many filtration systems were produced by each one of the 5 employees in each one of the ABC methods. Again, we have 15 employees. Okay, and let's take a look at my proposed steps. Develop the null and alternative hypothesis. So let me show you what the null and alternative hypotheses are. So step number 1. Step 1. My one is so bad. The mean for filtration system A is equal to the mean of filtration system B, which is the mean of filtration system C. Okay. And the alternative hypothesis is that the means are different, or at least 2 means are different. Okay. So I'm done with the hypothesis. It's always like this. Compute sample size, mean, and variance. Okay. So let me go back to the data. Where is the data? No. It's too much. It is here. Okay. So step number 2. Step number 2. The mean A, mean B, and mean C. Mu C, and then I have to compute all these means. So let's imagine you have the raw data like in here. Okay, so what you have to do is compute the mean. Remember, you know how to compute the mean using Excel. I'm gonna maybe do only once. I don't want to do it for all groups because otherwise it's gonna take too much time and this video is gonna be too long. But assuming you have the raw data, you compute the mean. Remember, mean is equal average, and then you compute the mean. Mean is 62. So let me go back there. Okay, so here's the mean, 52. Then you compute the variance using Excel too. Remember, the variance equal var.s. This is the variance, the formula for variance. 27.5, and sample standard deviation is stdev.s because it's a sample. And then, so this is how you compute the mean, variance, and standard deviation for each one of the groups. So this is compute sample size, mean, and variance for each group. So going back to here, we know the mean. Let's say the variance for each group is s squared for B, s squared for C, for A. So you compute these numbers, okay? And then after that, you compute the mean of the means for all groups. How you compute the mean of the mean for all groups? So let's go back there. I believe I have here hypothesis. Let me see. I don't have the mean for the means. Let's compute it together. So to compute the mean of the means in this case, because all groups have the same number of observations, you simply sum the sample means and divide by 3. So let's do that in Excel. 62, 66, and 52. So it's 62 equals 62 plus 66 plus 52, and I have to divide by 3 this sum, so I have to put within parentheses and divide by 3. So the mean of the means, that's very important. This is called the mean of the means. Okay, those were the sample means. I'm sorry, those were sample means. This is the mean of the means is 60. Okay, so this is what my steps telling you to do. Compute sample size mean variance for each group and mean for all groups. Compute the sum of squares treatment and SE. So let's take a look how the formula is for these guys. Sum of squares treatment. Here, sum of squares treatment. So what I have to do is, let me do it here. Sum of squares treatment is for the case 1. Let me do this better. Let me wait to show up. Is n. So the overall formula is n1 minus. Okay. So for the group 1, I have 5 observations. 5 observations multiplied by the mean of group 1, which is 62. How can I know the mean? Remember, I took note, but it's in here in the problem. So the mean is 62. So the mean multiplied by the mean 62 minus the overall mean, which is 60. Here is the overall mean. Okay, so I implemented this thing right here for the first group. So it's going to be 5 multiplied by 2, which is 10, right? Then for group B, I have 5, also 5 observations. The mean for group B is 66. 66 minus 60. Oh, I have to square this, okay? You have to square. So it's 20. This is squared. This is squared. And then 5, the difference here is 6 squared. And we'll have a number. Let's take a look at which number this is very quickly. Here is. I don't have the number, but let me do that in Excel. Okay, so I'm use Excel here. So 36, 6 multiplied by 6 is 36, multiplied by 5. 180. So this is 180. And for group C, I also have 5 observations. And then I have 66 minus, I'm sorry, 52. This third one is 52, right? 52 is the sample mean for group C. 52 minus 60 squared is 5. 52 minus 60 is minus 8 squared, which is equal to 64 multiplied by 5, equal to 64 multiplied by 5, which is 320. So the sum of squares due treatment is equal to the sum of this number, and this number. Okay? So that's the same thing we have here on these slides. Sum of squares treatment, the same thing I showed you, which is 520. Okay, so let's take a look at the next one. The next one is what is it? Oh, it's here. Compute the sum of square error. So the sum of square error, let's take a look at the formula. Formula is here. Sum of square error is equal to the summation of a and j number of groups minus 1 multiplied by the variance of each group. Okay, so let's do for group A. What I have is 5 minus 1 multiplied by the variance. I don't remember how much the variance is. So let's take a look at my table again, assuming that I computed everything. Like in here, the variance is 27.5 multiplied by 27.5. For group B, I also have 5 observations, sample size minus 1, multiplied by the variance. The variance is 26.5. And group C, I have 5 observations minus 1, multiplied by the variance of 31. Okay, so if I compute these numbers here and sum them, is the same thing I have in here, sum of square. It's 4 multiplied by 27 and a half, 4 multiplied by 27 and a half, plus 4, 5 minus 1, 4, multiplied by 26 and a half, plus 4, 5 minus 1, 4, multiplied by 31. So the summation is 340, which is equal to 340. Okay, I did that. So this is the second step, okay, on my sequence of steps. The third step, I developed the null, I compute this, I compute the sum of squares, now I compute the degrees of freedom. The degrees of freedom are here. So step number 4, degrees of freedom 1 is equal to k minus 1. K minus 1 is the number of groups. How many groups I have? 1, 2, 3. I have 3 groups minus 1 is equal to 2. Degrees of freedom 2 is equal to total sample size minus k number of groups. Total sample size, I have to count. I have 3 groups and 5 people in each group. 5 people multiplied by 3, 15. 15 minus how many groups? 3 groups. So these are my degrees of freedom 1 and degrees of freedom 2. Okay? Okay, let's go back to my steps. So I compute degrees of freedom. Now I compute the mean square do treatment and mean square error. So let's go back. So step number 5, mean square treatment, mean square error. Okay, so this is going to be equal to the sum of squares do treatment divided by k minus 1, and this is equal to sum of square error divided by total sample size minus k. I have these numbers, remember, so let me get those. The sum of square do treatment is 340. Okay, 340 divided by, so let me see here, if I go back, 12. Okay, so it's 340 divided by 12, and the mean square do treatment, let me go back 2 pages, is I'm waiting for the Windows this screen to show up. I'm gonna stop here because I have only 15 minutes to record the video, and I'm gonna continue the next video.